Using a contactor for transfer switching is legally permissible if you ensure certain conditions are met. Firstly, the contactor must be rated for at least 200 amps, as required by most building codes. Secondly, the contacts must be isolated and not allow neutral to ground bonding. Thirdly, the contactor must be connected to a circuit with appropriate overcurrent protection. The steps to use a contactor for transfer switching are as follows. 1. Install the contactor in a suitable location, such as an outdoor electrical enclosure. 2. Connect the normally closed contacts to the panel feed. 3. Connect the coil of the contactor to the power company's service entrance. 4. When the power goes out, the contactor will open the normally closed contacts, disconnecting the panel from the power company. 5. When backup power is available, connect the generator to the contactor's coil. This will close the contactor and transfer the panel to backup power. The cost of a basic 200 amp transfer switch can vary depending on the features and quality, but expect to pay around $150 to $300 for a basic manual transfer switch. It is essential to install an interlock system to prevent backfeeding into the utility grid, achievable with a mechanical or electrical interlock. Ensure that the neutral wire is properly bonded to ground both in the service entrance and at the generator. All electrical work should be performed by a licensed electrician. While using a contactor for transfer switching is a low-cost option, it requires careful planning and execution. For safety and reliability, it is generally recommended to use a dedicated transfer switch designed for generator backup. In more detail, let's discuss using a contactor with normally closed contacts for transferring power. A contactor acts as a switch controlled electrically, and in this configuration, it defaults to allowing power to flow through its normally closed contacts. When voltage is applied to the coil, it opens those contacts. This setup can be used to switch between utility power and generator power. When utility power is present, it energizes the contactor coil, opening the normally closed contacts and disconnecting the generator feed. When utility power is lost, the coil de-energizes, allowing the contacts to close and connect the generator to the electrical panel. The building codes often mandate that a transfer switch or a similar mechanism be rated to handle the full amperage of the service. In this case, a 200 amp service requires a contactor rated for at least 200 amps. Using a smaller contactor could lead to overheating, failure, and potentially a fire hazard. It's also crucial that the contactor is rated for the appropriate voltage, typically 120 volts or 240 volts in residential settings. Isolated contacts are essential for safety, preventing a direct connection between the neutral and ground when switching between power sources. The National Electrical Code, or NEC, specifies that the neutral conductor should only be bonded to ground at one point, usually at the main service entrance. Bonding the neutral to ground at multiple points can create ground loops, leading to unwanted current flow through the grounding system, which can cause nuisance tripping of ground fault circuit interrupters, or GFCIs, and potentially create a shock hazard. Overcurrent protection, such as circuit breakers or fuses, is necessary to protect the contactor and the circuits it feeds from overloads and short circuits. The size of the overcurrent protection should be matched to the ampacity of the conductors and the rating of the equipment being protected. In residential settings, this typically involves circuit breakers rated for 15 amps, 20 amps, or 30 amps for general lighting and appliance circuits, and higher ratings for larger appliances like air conditioners or electric stoves. When installing the contactor, choose a suitable enclosure to protect it from environmental factors such as moisture, dust, and physical damage. Outdoor electrical enclosures are often made of metal or non-metallic materials like fiberglass or plastic, and they are designed to meet specific NEMA, or National Electrical Manufacturers Association, ratings for protection against various environmental conditions. The enclosure should be large enough to accommodate the contactor, wiring, and any other necessary components, with adequate space for ventilation to prevent overheating. Connecting the normally closed contacts to the panel feed involves wiring the contactor into the main electrical panel of the building. This should be done by a qualified electrician, following all applicable electrical codes and safety standards. The wiring must be properly sized to handle the anticipated load, and connections should be made securely to prevent loose connections and arcing. The coil of the contactor, when connected to the power company's service entrance, will energize whenever utility power is available. This connection should be made through a suitable control circuit, often involving a step-down transformer to reduce the voltage to a safe level for the contactor coil. The control circuit should also include overcurrent protection to protect the coil from damage due to shorts or overloads. When the power goes out, the contactor will automatically switch to the generator feed, restoring power to the essential circuits in the building. This automatic transfer is one of the main advantages of using a contactor for this purpose, as it eliminates the need for manual intervention during a power outage. To ensure safe and reliable transfer of power, it's crucial to test the system periodically and perform regular maintenance on the contactor and related components. Connecting the generator to the contactor's coil closes the contactor and transfers the panel to backup power. This setup ensures that when the generator is running, it supplies power to the designated circuits in a building. This connection should be made through a properly wired receptacle and plug, with appropriate safety interlocks to prevent accidental backfeeding of power into the utility grid. A basic manual transfer switch might cost between $150 and $300. The cost depends on the amperage rating, features, and brand. Higher amperage switches and those with additional features, such as surge protection or remote monitoring capabilities, will typically cost more. Automatic transfer switches, which automatically switch between utility and generator power, are significantly more expensive, often costing several hundred to several $1,000s, depending on their size and features. An interlock system is critical for preventing backfeeding into the utility grid, which can be extremely dangerous for utility workers and can also damage equipment. A mechanical interlock typically involves a sliding plate or a similar mechanism that physically prevents both the main breaker and the generator breaker from being turned on at the same time. An electrical interlock uses relays and sensors to achieve the same function, ensuring that only one power source can be connected to the electrical panel at any given time. Grounding is another essential safety consideration. The neutral wire should be properly bonded to ground at both the service entrance and at the generator to provide a safe path for fault currents. This bonding helps to prevent electric shock hazards and ensures that overcurrent protection devices will trip in the event of a fault. The NEC provides detailed requirements for grounding and bonding, which should be followed carefully when installing a generator and transfer switch. The electrical work should be performed by a licensed electrician. Electricians have the training, experience, and equipment necessary to perform electrical work safely and in compliance with all applicable codes and regulations. Hiring a licensed electrician can help to ensure that the generator and transfer switch are installed correctly and that the electrical system is safe and reliable. While using a contactor for transfer switching can be a low-cost option, it requires careful planning and execution. It is very important to understand the electrical principles involved and to follow all applicable codes and safety standards. For safety and reliability, it is generally recommended to use a dedicated transfer switch designed for generator backup. Transfer switches are specifically designed for this purpose and include built-in safety features such as interlocks and overcurrent protection. They also typically have a higher level of reliability than a makeshift system using a contactor. In summary, while it's possible to use a contactor for transfer switching, the potential risks and complexities often outweigh the cost savings. Investing in a proper transfer switch is generally the safer and more reliable option. The purpose of an interlock is to prevent the generator from feeding power back into the utility grid, a situation known as backfeeding. Backfeeding is dangerous because it can energize power lines that are assumed to be dead, posing a risk to utility workers who may be working on those lines. It can also damage the generator and other electrical equipment. Mechanical interlocks are physical devices that prevent the main breaker and the generator breaker from being on at the same time. They typically consist of a sliding plate or a similar mechanism that blocks one breaker when the other is on. Electrical interlocks use relays and sensors to achieve the same function. They sense the presence of utility power and prevent the generator from being connected to the electrical panel when utility power is present. Grounding is a critical safety measure that helps to prevent electric shock hazards. The neutral wire should be bonded to ground at the service entrance to provide a low impedance path for fault currents. This ensures that overcurrent protection devices will trip quickly in the event of a fault, disconnecting the power and preventing a shock. The generator should also be grounded, typically by connecting it to a grounding rod or to the building's grounding system. The NEC specifies the requirements for grounding and bonding, which should be followed carefully. A licensed electrician has the training and experience necessary to perform electrical work safely and in compliance with all applicable codes and regulations. They can ensure that the generator and transfer switch are installed correctly and that the electrical system is safe and reliable. It is generally recommended to use a dedicated transfer switch designed for generator backup. Transfer switches are specifically designed for this purpose and include built-in safety features such as interlocks and overcurrent protection. They also typically have a higher level of reliability than a makeshift system using a contactor. A transfer switch can be manual or automatic. A manual transfer switch requires the homeowner to manually switch between utility power and generator power. An automatic transfer switch automatically switches between power sources when it detects a power outage. Automatic transfer switches are more expensive but provide a high level of convenience and safety. The cost of a transfer switch can vary depending on the amperage rating, features, and brand. Higher amperage switches and those with additional features such as surge protection or remote monitoring capabilities will typically cost more. The installation of a transfer switch typically involves connecting it to the main electrical panel and wiring it to the generator. This work should be performed by a licensed electrician. Regular maintenance of the generator and transfer switch is important to ensure that they are operating properly. This includes checking the oil and coolant levels in the generator, inspecting the wiring and connections, and testing the transfer switch to ensure that it is switching properly. Consider the load requirements when selecting a generator and transfer switch. The generator should be sized to handle the anticipated load, which includes all of the appliances and equipment that will be powered during a power outage. The transfer switch should be rated for the same amperage as the generator. Also think about the fuel source of the generator. Generators can be powered by gasoline, propane, or natural gas. Each fuel source has its own advantages and disadvantages. Gasoline is readily available but can be expensive and can degrade over time. Propane is cleaner burning than gasoline and can be stored for longer periods. Natural gas is the least expensive fuel source but requires a connection to a natural gas line. Noise is another factor to consider. Generators can be noisy, so it is important to choose a model that is as quiet as possible. Some generators have noise reduction features, such as mufflers and enclosures. Location is also important. The generator should be located in a well-ventilated area, away from windows and doors. It should also be protected from the elements. Carbon monoxide is a deadly gas that is produced by generators. Never operate a generator indoors or in an enclosed space. Install carbon monoxide detectors in your home to alert you to the presence of carbon monoxide. Electricity is dangerous, and it is important to take precautions to avoid electric shock. Always turn off the power before working on electrical equipment. Wear rubber gloves and eye protection when working with electricity. If you are not comfortable working with electricity, hire a licensed electrician. The National Electrical Code, or NEC, is a set of standards for the safe installation of electrical wiring and equipment. The NEC is updated every 3 years, and it is important to follow the latest edition. Local building codes may also have requirements for the installation of generators and transfer switches. Permits may be required for the installation of a generator and transfer switch. Check with your local building department to determine the requirements in your area. Before purchasing a generator and transfer switch, it is a good idea to get several quotes from different vendors. This will help you to compare prices and features. Be sure to ask about installation costs and warranty information. In summary, Using a contactor for transfer switching can be a low-cost option, but it requires careful planning and execution. For safety and reliability, it is generally recommended to use a dedicated transfer switch designed for generator backup. Always follow all applicable codes and safety standards, and consult with a licensed electrician if you have any questions. Remember to consider the load requirements, fuel source, noise level, location, and carbon monoxide safety when selecting a generator and transfer switch.